Okay, here's some more problems from the antiderivative worksheet. This is number 25, and we're finding exact solutions. So just kind of think about this. We're given the equation f of x equals a cosine of x, and we're looking for the antiderivative of this. And we're given what we call a particular value, and sometimes it's referred to as an initial condition, but it's a value of a point that is actually on the antiderivative. That way we can actually find out what the constant is. Now, first of all, if we want to try to find the antiderivative of this, remember, we're just going backwards. In other words, if we have this on our flashcard, y equals the sine of x, we know that the derivative of the sine of x is the cosine of x. So y prime equals the cosine of x. So we're trying to go backwards. We're saying, well, this is the derivative, what's actually the antiderivative. So what did we take the derivative of to get this? So we just flip it back, and it's going to be the sine of x. Now, just for future reference, we use antiderivatives to solve these kinds of equations. In other words, this part of the solution for this equation is the antiderivative, which is the sine of x. And then we can actually find the particular solution, or find the value of c with this added information. When we have this is actually a derivative. We call this a differential equation. And we use antiderivatives to solve differential equations, and we'll get to that a little bit later in our book. But right now, let's just find the antiderivative. So we know that if this is the derivative, the antiderivative would be sine of x. So we've got part of our answer, f of x equals the sine of x. And we know the derivative of the sine of x is the cosine of x. But we also know that the derivative of the sine of x plus 2 is the cosine of x, and the sine of x plus 3 is the cosine of x, and the sine of x plus 10 is the cosine of x, because whatever constant I put here, if I take the derivative of a constant, I get 0. So we don't really know what that is. It could be a lot of numbers. So we have to put a c there. And that's as far as we can go unless we have what we call an initial condition, or some particular value of a point that's actually on our antiderivative, and we do have that. Now remember, this belongs to the antiderivative, so this would be my domain element, x, and this would be my range element, y, or sometimes called f of x, and in this case it would be capital F of x. So we have that information. So when f of x is 9/2, we know that x is pi over 2, so we just substitute that in. So when f of x is 9/2, we know the sine of x, and x is going to be what? Pi over 2 plus c. Then we have enough information to find out what c is. It's pretty easy. Okay, so 9/2 equals, and the sine of pi over 2, well, we know from our trigonometry the sine of pi over 2 is 1, so it's 1 plus c. And that implies, well, 1 is the same thing as 2/2, so if I subtract 2/2 from both sides, I get 7/2. And there's my c, as long as this point belongs to my antiderivative. So my complete antiderivative, f of x equals the sine of x plus c, and c is 7/2. So there you go. Now hopefully you're trying these problems first, checking the answers, which are on my school website. And then if you don't get the right answer, then you come back and check this. So if that's not the case, then the rest of the problems, please go back and try the rest of the problems, 25 through 38. And do the work, and then if you can't figure it out, or if it doesn't make sense, then you can come back and look at the video solutions. But please try the work first. Just don't copy down the solutions. You're not going to learn anything that way. Okay, 26. F of x equals 1 over 2 times the square root of x. And my given value is 4,1. The point 4,1 belongs to the antiderivative. That's what we're looking for. Okay? Now, if you haven't done this, you can always just pause it right now, pause the video, try the problem, and then come back and check to see if you did it correctly. All right, so this looks definitely like the derivative of the square root of x. It's one of our formulas. Remember, the derivative of the square root of x is 1 over 2 times the square root of x. So the antiderivative is going to be the square root of x, but again, plus c, because we don't know what that constant's going to be. But we do have enough information to find it because we know that this is going to be f of x, or this is going to be x, excuse me, and this would be capital F of x. And we sometimes call this xy, xf of x, or even we call it x of this over here. We could call it x square root of x. Okay, so we know that f of x is 1. And that equals the square root of x, and x is 4, plus c. And that's going to imply, and I guess we can work this out like this. So 1 equals, and then what's the square root of 4? The square root of 4 is 2 plus c. And if we subtract 2 from both sides, then that's going to imply that c equals, or subtract 2 from 1, we get negative 1 equals c. So now we have our value of our c, so we just put that in here. So f of x, capital F of x, equals the square root of x, and c is minus 1, so minus 1. Okay? So not too difficult, just have to be careful.